Well, good afternoon, everybody, and welcome along to DBA Fundamentals Down Under for the month of July. This month, we've got Tim Mitchell talking to us about the introduction to SQL Server temporal tables, and I'll hand over to Tim very shortly. I just have a couple of slides to run everybody through as part of some housekeeping for this month's session. So just to let you all know, this session is being recorded and will be available on the DBA Fundamentals archive site after this session. If you do have any questions at all during the session, feel free to raise those in the question box. I will be monitoring those and asking those questions for you to Tim throughout the session. For those of you who don't know, if you don't know SentryOne, please go to SentryOne's websites. Big thank you to them for being our sponsors, as without having sponsors, it makes it difficult to continue putting on these free monthly sessions for you. The other side of it, make sure that you stay connected with PASS. For those of you who have not already registered for PASS Summit later this year, the regular sessions were all announced last year, so all sessions and speakers have been announced, and there's a great lineup of speakers available. So make sure that you register, go along for a great week of learning. So with that, we'll hand over to Tim.
All right, thanks, Warwick. Let me show my screen so everybody can see the presentation. All right, and if that's working properly, you should be able to see my PowerPoint.
Yes.
So welcome, everybody. I appreciate you taking the time to join me this, wherever you are, afternoon or evening. For most of you, it's probably afternoon. For me, I'm in the Dallas, Texas area, so it's about 9:30 p.m. my time. Wherever you are, appreciate you joining. Certainly, it's good to be acquainted with you virtually. As Warwick mentioned, we're going to talk a little bit about temporal tables. This will be a fairly introductory presentation. I want to give you an idea of what temporal tables are, just a high-level overview of how to use temporal tables, some of the use cases, and things like that. So by way of agenda, we'll start off with just a quick overview. I'll describe to you what temporal tables are. I'll talk a little bit about how to create and manage those. It's a little bit different than managing a conventional table in Management Studio. We'll talk about how to do the basic querying and then loading of that data and how that will look whenever you're managing those temporal tables. And then most importantly, I've got some demos. We'll get through a few slides and then I'll jump in and show you realistic exercises of how you can use those temporal tables. So a little bit about me, for those who don't know me or whom I haven't met. My name is Tim Mitchell. I'm a BI consultant and a business owner. I run a company called Tylerus Data Solutions. We specialize in ETL, data warehousing, reporting, and things that touch those moving parts within a data warehouse. I'm a 10-time Microsoft Data Platform MVP. If you want to keep up with some of the various things that I do as far as publication, I write at timmitchell.net. And if you're on Twitter, you can follow me at Tim_Mitchell. A few housekeeping items. As Warwick mentioned, we do have some time for questions. We've got probably 40 or 45 minutes worth of material. So we do have some built-in time for questions. I'll pause in between the slide deck and the demos, and then I'll have some time after the demos as well for any questions. And then everything that you see here, the slide deck, as well as all the code that we use, will be available for download. I'll send that to Warwick in case there's a way to put that on your virtual group's website. I'll also have it on my website as well, just in case you need another download location. So we'll start off with an overview and talk about what temporal tables are, how they fit into the SQL Server ecosystem, and how those can be used. So first of all, we'll talk about a definition. What are temporal tables? So simply put, these are system version tables that allow or have SQL Server controlling the version history that you have in those tables. So basically, all the prior versions of every row that you have, they're not lost whenever you do your inserts, your updates, or your deletes, but rather those are actually stored in history. They have a dedicated history table for every temporal table that you create. And if you have if you have updates, if you have deletes, rather than that old data just going away, it's actually stored in that history table. So you can query it for a specific point in time rather than what it just looks like right now. All of that versioning is based on the date stamp whenever the activity takes place. One thing I'll mention briefly is that all of that date stamp versioning is based in UTC. So if you're not already familiar with UTC or you're not using it in some way, you do have to make a little bit of mental adjustment to know that you're dealing with UTC. And this was introduced starting in SQL Server 2016. So 2016, 2017, and then the Azure-based versions also have this as well. So temporal tables will allow you to look at what the data look like, either what it looks like right now, as far as the current state of that, or go back at any point in time since that temporal table was created and see what that data look like. So if you're dealing with, for those of you who deal with a data warehouse, I do a lot of data warehouse work. If you deal with a data warehouse and you want to see what did it look like 3 days ago, what did it look like this same time last year, you can easily query that temporal table to see what did it look like at any given point in time. And by default, that history is stored indefinitely. Now, I put an asterisk beside this because there is a qualifier here. If you're using SQL Server 2017, there was a change made to 2017 where you can specify a retention period in which it'll only keep that data being effective for a specific amount of time. But the default setting is for it to keep that data indefinitely, even if you're dealing with SQL Server 2017. So some of the use cases that you'll probably come across, if for any reason, if you need to keep whatever version of a table, whatever version of those rows was in effect or was stored at any given point in time, this is a fantastic case for that. There's lots of different moving parts or lots of different scenarios where you might want to keep those types of data. One of the ways that I use it, and again, I do a lot of data warehouse work, is if I'm dealing with a slowly changing dimension, and it's any sort of slowly changing dimension that I might want to have historical versions stored, temporal tables can be a good option for that. One of the advantages here is that for those of you who do or have dealt with data warehouses, a lot of times you have a decision point when you're designing that data warehouse. Do you want to make that a type 1 dimension where you don't store any history, or a type 2 dimension, where you are storing the full history? The good news here is if you use a temporal table for that purpose, you don't necessarily have to make that decision at design time. Because if you use it as a simple type 1, when you query that table, it just returns the records that are currently stored in there, whatever that current version of that row is. But if you use the temporal table functions and say, I want the data as of a particular day, then it starts to function or perform the functions of a type 2. So it alleviates a little bit of that design work or a little bit of that decision making ahead of time. By allowing you to work that as both a type 1 and a type 2 at the same time. One of the things that I'll typically mention if you do decide to use this as a slowly changing dimension table, one of the minor shortcomings that I have found in temporal tables is that you can't specify the date on which an old row expires and a new row takes its place. In a lot of cases, this is okay. If you allow whatever time the ETL runs, for example, to dictate when the old row is no longer in effect, the new row replaces it, then that's okay. But if you need to use some sort of application time where the application itself that you're getting the data from needs to specify when the old record expired and the new record took its place, temporal tables probably wouldn't be a good solution for that type of slowly changing dimension. But if you don't have that requirement, for slowly changing dimensions, temporal tables are a really good way to implement this history tracking and history retention. You can also use it for change auditing. So if you need to track over time, this value was X, then it was Y, and now it's Z, and to know when exactly that took place, it can be an effective change auditing tool. And again, here I put an asterisk as well, because if you want to build change auditing from a regulatory perspective, for example, if you need to know who changed the data, temporal tables will not give you that information. It doesn't tell you who changed it from what workstation or any of that information. It simply tells you this is the data that existed before, this is the value that it was replaced with. So if you have lightweight change auditing needs, it can work for that. But again, if you need full-on regulatory needs and see who all touched that data along the wire, it doesn't give you that level of granularity, unfortunately. So that's a brief definition of what temporal tables are. Let's talk a little bit about how you create and manage those temporal tables. So as I mentioned earlier, you do have to have SQL Server 2016 or newer. It doesn't depend on any specific version of SQL Server, or rather edition of SQL Server. So whether you're using standard all the way up to enterprise, and I believe even express, they all have temporal tables built in. So you don't necessarily have to have enterprise to run this. For any table that you enable the system tracking or temporal table functionality, that table does have to have a primary key. It can be a single column primary key. It can be a multi-column primary key, as long as it has a primary key on that table. And then finally, you have to have on that table, or create when you set temporal table up on that table, you have to have two non-nullable columns that will be used for the start date and the end date, basically the bookends for when that row is valid. The scripts that I'll show you in a little bit actually have that built in where it creates those columns for you. But that is a requirement that you have to have that. So basically, if you're using SQL Server 2016, if the table that you want to enable system change tracking has a primary key, you're all set. You've got everything that you need from that point. Now, one thing you have to get used to is if you go into Management Studio, ordinarily, if you want to create a table, if you want to manage a table, see all the columns that are on that table, for example, you can easily do that in the UI. That's not the case with a temporal table. So as soon as you enable temporal functionality on a table or create a brand new table with temporal functionality, two things will happen. You'll see the UI experience like you see here, where for this example where I've got in the red box, you've got customers that is enabled as a temporal table. It's going to show that decoration that it is system versioned, but you also lose the ability to manage that through the UI. So if you right click on that table, you can't go in like you can with a conventional table and see all the columns. I suspect the reason for that is whenever you're creating that table or you're managing that table, let's say you add a column to the temporal table. It's got two different options that need to, or two different operations that need to take place. And I suspect it's probably a hard thing to automate through the UI. So you actually have to do all your administration. You're creating the table, turning off temporal functionality, adding columns, deleting columns. Those all have to be done through T-SQL, unfortunately. For those of you who are a fan of doing T-SQL operations anyway, that's not necessarily bad news. I would rather have a T-SQL script rather than something that I have to go through the UI on, because I can more easily reproduce and make that a repeatable operation if it is a script. But just be aware that you can't manage a temporal table in the UI in the same way that you manage a conventional table in Management Studio. So whenever you create your temporal table or you modify an existing table to enable it for temporal functionality, a history table will be created. This is a full-on physical table. So if you browse your list of tables, you query sys.tables, you're going to see that history table there. You can do one of two things when you're setting up the temporal table. Either you can specify, you can have it create a new history table, or if you already have a table that matches the metadata on the base table, you can use that existing table. The latter option is really handy for if you want to import history. For example, if you're pulling in, getting back to the data warehouse example, if you're using a slowly changing dimension and you want to take what used to be a slowly changing dimension and make that into a temporal table, you could take that historical information, import that into a new table for the purposes of being a temporal table history table, and then use that existing table rather than creating a new one. Now, honestly, in my experience, you're rarely going to do that. In almost every case, you're going to create a brand new table. You're going to have it create a brand new table, hopefully with a name you specify, and then load that table if you need to do any sort of import of the history. Because that history table is a physical table, you can query that history table directly. So if we're going to call our base table a people table, most likely we're going to call our historical table people history. And you can query that, you can select to your heart's delight on that table. For obvious reasons, as long as you have temporal functionality enabled on that, you can't modify that history table directly. So you can't update, you can't delete, you can't make any changes to the underlying history table. If you need to change anything in the history table, obviously you're going to interact with the temporal table itself, which will result in modification to that history table, which is read-only. And as I mentioned, you can import that history. What you have to do if you're importing the history is either you have to do that, you have to create your history table, then turn off the temporal functionality, import the history and turn the temporal functionality back on, or create the history table ahead of time without having turned on temporal functionality. Do your load of that history that you want to create and then turning on temporal functionality. Honestly, I found the easier thing to do from a syntax perspective, and just to make sure that you've got the correct metadata. If you do need to create a history table and then load it with some data, my best recommendation is go ahead and create your temporal table, specify the name of the history table. It's going to create that empty history table, and then turn off the temporal table functionality on the table you just created. Go ahead and import your history into that history table and then turn back on the temporal functionality. It actually involves more steps than simply creating the empty table, loading it, and then turning on the temporal functionality. But what that does is it makes sure that the history table that you're creating has the exact metadata that it needs, column by column, to match the base table for which it's storing the history. So again, more steps, but it makes for a more efficient process in my opinion. So that's a little bit about creating. Let's talk a little bit about how you query that table once you've created it. So ordinarily, if you have a table, you can say select star from this table, put in whatever where clause you want. The good news is for a temporal table, that's exactly the same way that you create that, or that you query that. If all you want to do is look at the table and the rows that exist right now, select star from table name, or select column name, column 2 name, column 3 name, and so on, just like you would any ordinary table. Now, when you're doing that, as far as getting the results back, that works just like a regular table in that it shows you what the data looks like right now. You're actually not hitting the history table at all whenever you're doing a regular query against the table. That will show you the current versions of those rows. Same thing with updates and deletes, or inserts for that matter. The syntax is exactly the same. If you're updating, deleting, inserting data, insert into table, column list, or however you want to insert. All the bulk operations as well. Those work exactly the same. The only difference is under the hood, it's storing, if you're doing any sort of update or delete, it's storing the old version and moving that over to the history table as part of that operation. So there's a couple of functions that you're going to want to keep in mind when you're dealing with history table or the temporal tables. If you want to look at a specific point in time, you're going to want to remember for system_time. So there's a couple of different functions that you're going to use. The most common one, if you're using for SystemTime, it's going to be the first one that you see in that sub bullet. For SystemTime as of a given date time to value. That's saying I want to see whatever the data look like as of 5 minutes ago, 5 hours ago, 5 years ago, and it's going to show you whatever that data look like as of that date stamp. If that date stamp happens to predate the table, so if I create my temporal table today, or let's say I created the temporal table yesterday, I query that table today, it's going to show me what the data looks like as of right now. If I use for SystemTime as of yesterday, it'll show me whatever that was yesterday. But if I created the table yesterday, loaded it yesterday, I say for SystemTime as of 2 days ago, UTC, I'm going to get an empty table because at that point in time, there weren't any rows in that table. Technically, the table really wasn't created. So that's kind of a different thing. But as far as the effective dates for that data goes, if I go back before I inserted any data at all, it's not going to find any records in there. So I'll just get an empty table at that point. So do be aware of that. So again, that's the most common use for SystemTime as of a given point in time will give you whatever that data looked like at that point in time. For system time between X and Y. So if you want to see what the data look like between two dates, again, a much less common need. You can specify two date time two values, again, in UTC, and it's going to give you everything between those two date periods. And then below that, from works very similar. The only difference between the between operation and the from operation is that between is inclusive and from is exclusive. So between will give you everything starting at X and ending at Y, including X and Y. And then from will give you everything from X to Y, but not including the X and Y periods. And then finally, for system time all, that's going to show you the full history of that table. So basically, that's going to be a big union all between the current table and the history table. So if you've got, let's say for your Tim Mitchell record, if you're talking about a person, if you change Tim Mitchell 15 times, you're going to see 16 different versions of Tim Mitchell, whatever the current version is, and then those 15 changes that you've made over time whenever you do for system time all. Again, for system time between, from, and all are lesser needed functions. They're really handy to have if you need them. But more often than not, you're going to need either for system time as of a specific point in time, or simply leave off the for system time entirely. And that's going to show you what the data looks like as of right now. All right, so that's our quick overview. I talked a little bit about how it works for querying, for loading the table, for managing the table. Before we jump into the demos, Warwick, do we have any questions that have popped up that we need to address?
Not at this stage, Tim.
All right, perfect. So I've got a set of scripts that we'll go through. I'm actually starting, I've got a script that even deletes or rather drops and then recreates the database that we're dealing with. There's nothing fancy in this drop and recreate function, but what I want to do in that is start off with a brand new fresh database so you see from the very beginning how we create and load that table. So I'm going to go ahead and run that query to drop and create that database. I've got another table, or rather another query that will drop and recreate my customers table. So you can see that we're dropping two different tables, customers and customers history. Before I do that, I'm querying to see, and this is a handy query that you can use to see if a particular table is set up for temporal functionality. If you're querying sys.tables, where the object ID equals whatever the table name is that you're looking for, and then the temporal type is greater than 0, then we know that temporal is turned on for that table. If I do have a table that's enabled for temporal functionality, I can't simply drop that table, and by extension, I can't drop the history table either. So for any table that does have temporal functionality turned on, I have to turn off the temporal functionality, the system versioning functionality, and then I can drop that table after I do that. So that's what I'm doing here, recreating the base table. I'm inserting some various data, so I'm actually pulling some data from my wide world importers database and inserting a starter set of data in there. So we'll go ahead and add that in. Now, right now, this is not a temporal table. So this is not a system version table at all. This is just a regular old table. One other thing that I'll call out is you can see that I've got a couple of lines commented out here. Previously, I had in the script my valid from and valid to columns. So these are the ones that define the period that row will begin being effective and the period that it expired or it was no longer effective. I've commented that out because I wanted to have an all-inclusive script that showed how to create those columns, to populate those columns, and so on. But do keep in mind those column names, that those are the same column names that we're going to use for the valid from datetime to and the valid to datetime to in just a second. So up to this point, we haven't done anything with regard to temporal table. Let's go ahead and create or open up that script to create the temporal table. So we're going to do two things whenever we do this. The first thing we're going to do is I'm going to alter table customers. I'm going to add two columns. I'm going to add a valid from and valid to, just like I mentioned a minute ago. Those are both going to be of date time to data type. There's a little bit of odd syntax that if you've never dealt with temporal tables, this is going to look a little odd to you. I've dealt with temporal tables and it still looks a little odd to me. When you're adding these columns, this generated always as row start hidden and generated always as row end hidden. That's some specialized language that's required by SQL Server for those columns to indicate that we're going to use those columns. They're going to be generated columns. We can't populate those columns with any values because they're going to be automatically generated. Specify as row start says that that's going to be the effective start date. As row end, that's the effective end date. And then hidden. This is a new attribute, again, specifically for temporal tables that will let me hide that column. So what will happen is when I hide that column and I say select star from that table, these two columns will not be present in that result set. But if I say select star, comma, valid from, comma, valid to, they will be there. If I call them out by name, those will be included in the result set. But when I mark those as hidden, by default, they will be hidden. They will not be shown. I can still query, I can filter by them, but unless I specify the column names in a result set, they will not be present in the result set when I query from that table. All right, so valid from, valid to, that defines those. And then finally, period for system time, that's a directive to the table saying for those two columns, I want to use the system time indicators, and my from and my to columns are these two columns that we named up here. Again, the syntax takes a little getting used to because you have to specify the two columns and then separately say period for system time to specifically call out that the valid from is my start, the valid to is my end period. So when I run that, that still doesn't turn on temporal functionality. To turn on the full temporal functionality, what I have to do is alter the table, set system versioning on, and then specify, here's where I specify the name of the history table. This is optional, so I could run just these two lines followed by an end bracket there and an end marker there, and just run those two lines. What it will do is if I do that, it's going to give a strangely named table that's just randomly assigned. It's not going to be table name history. It's going to be table name some string of characters. I don't want that. I want there to be some sort of a naming convention. Whatever naming convention you use, that's okay. But as long as there is some regularity to it, I prefer to have just history at the end of, so we have customers and customers history. If I had people, it would be people history and so on. But again, you do want to specify that, otherwise it will give you just some oddball name that it makes up. So we ran that. Let's go ahead and run those that execution. And now I'm going to expand out, follow me to the left just a little bit, down to my temporal sales database. I'm going to drill into my list of tables. And now that you can see, we've got customers. It does indicate that it's a system version table. If I expand this out just a little bit, you can see underneath there, we have separately enumerated the customer's history table. Again, this one will have the exact same metadata that we have in its parent table. The only difference here is that we're not directly modifying customer's history. Everything that we insert, update, delete in there is actually a function of interacting with the customer's table. But I can, to my heart's content, I can query that table as long as I'm only doing select operations against that table. One final thing to note is that in your history table, you will only find the expired rows in there. So right now, if I select everything from customers, you can see I've got 663 rows there. I'll go ahead and select everything from the history table, and I'm going to see nothing there. History is, just like the name implies, it's a history table. So until I change something, until I until I update or delete something that's in that table, you're going to see nothing show up in that history table. It is purely history, and it's only showing things that have actually expired. The last thing I'll show you on that is if I scroll all the way to the right. Oh, that's curious. That's showing, that should not show. Oh, I take that back. I do have valid from and valid to on there. let me reinforce what I was showing you just a second ago. Let me get rid of, I know this is not a best practice to do select star, but just for demonstration purposes, I'm going to do a select star on here. So did a select star, I'm going to scroll all the way to the right. So valid from and valid to are still valid column names on this table, but they are not showing up in select star because they're marked as hidden. If I specifically say valid from, valid to, then those will show up. But again, by virtue of being marked as hidden, unless I specifically indicate that I want to include those will not be included in there. And if I scroll down, you can see all those bear the same date and time because they were all part of the same batch. If you were doing something like, for example, I do a lot of work with SQL Server integration services. If you're doing anything that's batch related, like a data flow operation in SSIS, for example, you'll have your data broken up into separate batches, so they may not all bear the same valid from time, even if they're part of the same load. So you do want to be aware of that, that you can have a little bit of a shifting landscape as far as when that data was inserted. But again, it does reflect when the data was actually inserted and committed to that parent table. All right, so that's how we set up the temporal table. One alternative version that I want to show you is if you're dealing with SQL Server 2017, as I mentioned earlier, you can specify a retention period. So by default, everything is kept indefinitely. If you're using SQL Server 2017, you can optionally specify history retention period as part of your alter table statement, and specify how many hours or days or years that you want to keep that history. By default, this is an optional directive. So if you don't specify, it's going to be indefinite. One item of curiosity is that even though you specify the retention period, if you look in your history table, those rows that have expired actually don't go away. They still remain in your history table. But if you query that base table and say for system time as of X, and X predates your retention period, it won't show you anything at all. So do be aware of that. Physically, the rows are not deleted. They are just logically expired from that history table, okay? All right, so we talked about how to instantiate the table. We talked a little bit about the alternative version where we can specify the retention period and not keep things indefinitely. Let's look a little bit into how we query that table. So by far the simplest thing to do is to run a select query on there. The good news is that it looks just like a regular query on any other table. Let me get rid of valid from and valid to, since you've already seen that. Simply going to do a select star. What this will show me is what the data looks like as of right now. So I only loaded 663 rows of data. We haven't yet updated anything, so all 663 rows of data are still current and valid, and there is no history in the history table at this point. If I want to specify a specific date and time, excuse me, I can specify that by using for system time as of a specific date time to value. And what I've done here is use the SystemTime function to specify when I want that data to be in effect by using the get UTC date function that gives me whatever the UTC date is as of right now. Now, logically, this query and this query are identical because if I say I want the data as of right now, that's effectively what we're doing up here anyway. We're saying as of right now. So logically, this doesn't do anything at all. But just to prove that out, this is what we'll see. Same 663 rows because we're looking exactly as of right now. Let's look at a system time that predates the table, however. I mentioned if you loaded the table today, and then you run for system time as of yesterday, it's going to show you, it's not going to throw an error, but it's going to show you that you have 0 rows of data to deal with. So look at 2:24 UTC time, 2:24 AM, which is a little bit before we loaded that data. I'm going to get 0 rows. But if I put in 0302, that should give us enough of a window that we'll actually see some data. So again, if it predates the table or predates the insertion of some specific row, it's not going to show up in there. So do be aware of how you're using that. And then finally, I've already shown you this when I typed in the code a little bit earlier. You can specify, I want to see the valid from and valid to. For the most part, you're not going to necessarily care about that. But since I'm talking to mostly a DBA crowd, if you do want to see the full history, you want to look at that history table, see when the rows were expired, when they're valid to, and so on. You can easily do that by selecting directly from that customers table and then specifically including the valid from and valid to. So that's how you do your query. Let me go ahead and show you what data modifications look like. I'm going to do a few modifications here. I'm going to actually do those in batches because I want those batches to appear with different date and timestamps. So I'm going to go ahead and do an update here to one person. I'm going to do another update to a different person, yet another one here, and then I'm going to delete a handful of customers here. I put a wait for delay. Let me go ahead and let that start while I'm talking. I went ahead and put a wait for delay on here because I want to space out those operations just a little bit to show that you will have a different date and time on the valid from and valid to whenever you're expiring or updating records at a different point in time. So we've got our modifications made. Let me go ahead and go to our post modification script. So I'll show the customers, the updated customers as of what they look like right now. So 1, 2, 3, 4, 5, 6, 7 customer IDs that we're looking for. And we do have all 7 customer IDs because I'm looking at just the base table here. I can do the same thing with valid from and valid to if I'm interested in that. Now what I'm doing here is including the valid from and valid to, but I'm also saying for system time all. And if you'll remember, this will include not just what it looks like right now, but for all the changes that we made for those customers. This is the full change history, and I'm going to order by valid from. So if I look over all the way to the far right, I can see those changes. So I had one batch of changes at 256. That was probably the insert operation. I had another set of changes at 305.36, another at 305.39, and then yet another at 305.42 as those were changed along the wire. So what you can see is for every one of those operations, it's generating in my customer's history table another record in here. And because I'm saying for system time all, it's showing all those records, all the versions that we've ever had for each one of those customer key values. And again, if I exclude, just by example, if I exclude for system time all, then I only get those 7 base rows because we're only looking at what does it look like right now, okay? So if I want to see what that looked like as of a specific number of minutes ago, just by way of example, let me go back 4 minutes. I'm just kind of guessing here. So for that operation, let me see everything from customers for system time as of 4 minutes ago, where those customer IDs is in this list that we were looking at. And let's see what we have. So we have everything including, let me include the valid from and valid to, just so we can see what was expired and what was added as new. So everything that we're looking at that was there as of 4 minutes ago has since been replaced. So this was valid from 0256, which was our original insert, and then it was expired at, this one was expired at 305.36. The rest of those were expired in that second batch that we were talking about a little bit earlier. If I want to get a little more specific, let's see if we can go back 6 minutes. We probably get the same thing, shorten that up just a little bit further. You can see that we're dealing with a moving target here. So go back 2 minutes ago. Now this is where you can see the difference here, where all of these rows, if I go back only 2 minutes in time, this shows all those records that were replaced from the previous result set. So this one was valid starting 305.39. This was 305.42 all the way down, and these are currently valid because they have the valid to set to the infinity date, 12/31/99/99. So you can see how you can use that for system time all to see all the records, or for system time as of to see what it is at, or what it was at a specific point in time. Again, not terribly interesting if you're looking at minutes like we are right now, But if you're dealing with something like, hey, I want to compare my business, some business metric from right now as to what it looked like same time 3 months ago, or even same time last week, or same time a year ago, you can easily go back and specify for system time as of, compare that to where we are right now, and easily have your built-in history tracking where you don't have to create this complicated system of slowly changing dimensions or even slowly changing facts, where you're using temporal tables to do all of that for you automatically. All right, for my deleted customers, you remember that we had deleted a few customers. If I look at those 3 customers that we deleted, customer ID 23, 24, and 25, I shouldn't see those customers in my current history table. I'm sorry, my current customers table right now, because they were deleted. And in fact, that's what we see. So no customers in there. However, if I look at for system time all for those same 3 customers, I'm going to see here are those 3 records. They started off being valid at 0256 with that original insert that we did when we started the demo. And then they were all expired, or they went to their valid period as of that last update, or that last DML operation that we did where we deleted those 3 rows. For system time all will show you that information. And just in case you're curious, I mentioned earlier that we can directly modify, or we can directly interact with that history table as well. So you're not really supposed to type in a demo, but since we're all friends here, we'll go ahead and do that. From, instead of customers, you can see my handy Redgate SQL prompt is showing me the history, showing me the list of tables that match. Let's go to customers history, and I'm going to borrow from this code where customer ID in 23, 24, and 25. So effectively querying from the customer's history table is showing me the same thing that we saw up here, because that's going to show me the full history. The only difference here is, had this not been a delete, the select star from customers for system time all would show me all the versions, including the current version, whereby if I queried the customer's history table, that's only going to show me the history. Now, again, in this case, because we inserted those rows and immediately deleted them without having updated those specific customers, we're going to see the exact same result set. But if we had updated those customers and then deleted them, we'd see a little more history here. Or if we had a customer that was updated but not deleted, we would actually see more rows in for system time all, because that'll show us the current version as well as all of the old historical versions. In fact, just out of curiosity, let me, since we've got a little bit of time here, let me show you what that would look like. I'm going to borrow from that previous query, and one more time here. So I'm going to do 2 things. I'm going to query from customers for system time all. So this is going to show me throughout all of time all those records from customers and customer history where the customer ID is in that set. So I have altogether, I've got 15 matches there that include the current versions of those records as well as the historical versions. But if I only query, so I'm doing the same exact where clause here, but instead of querying from customers, I'm querying from customers history. This shows me only 8, because what we're excluding is, so up here we had 15. What we're excluding is the 1, 2, 3, 4, 5, 6, 7 records that are current for those customers. So we're leaving those out whenever we only query the customer's history table. And you can see that by querying that, we only see those records that have been since expired, but not the current record. If we want to see current and all of history, for system time all is the way to go for that. Okay, so you can see how once you modify some data, doing both updates and deletes, you can see how that's reflected in the underlying tables. And just a quick glimpse into that, I mentioned a little bit earlier that you can look at both the customers table, which gives me 660 rows now since I deleted 3. And then if I query from select star from customers history, the only thing we're going to see in there is what we have actually changed or deleted. So I only have 11 records altogether that I either changed and replaced some other version, or I simply deleted entirely. And if I cut that down to just one specific customer ID, in this case, we're looking for customer ID 13. You can see the difference that we have there. So the upper query gives me whatever that record looks like right now. The lower query shows me all the history for that. And then finally, if I do for system time all, that last query will show me all 3 records, which is a concatenation or a union all of everything from customers for that customer ID, and then all the change history for that customer ID as well. All right, and then finally, if you do want to turn off the versioning for this table, the way that you do that is alter table customers, set system versioning equals off. You'll notice that if I right click on that table, there's not really a way to do any of that. So I can't turn off system versioning. You see that I don't have, ordinarily I can right click and go to the designer and add and remove columns, change data types and things like that. I don't have that option whenever I'm dealing with a temporal table. I actually have to go through T-SQL to do that. And if I want to drop that table, let me go ahead and show you what that looks like. I'm going to go ahead and directly try to drop that table, and it's going to give me an error because this is enabled for temporal versioning, or it's got temporal table functionality set up on it. So as I mentioned earlier, if I want to drop either the base table or the history table, I have to set system versioning equal off. And then when I refresh my list of tables, now I see both tables here. Now you see that customers history is in here, but it looks like just a regular old table. So if I go expand that, all the columns that we had there, just like in the base table, those are all present. The difference here now is that the customers table right now is no longer tracking the history using the temporal functionality. And I can go in and modify any of the data in customers history, or I can delete that entirely if I so choose. Or if I'm modifying this and I decide, hey, I'm going to turn temporal functionality back on. Let me go back over to this query. So even though I've already created this table, so previously that history table didn't exist. So when I ran alter table customer set system versioning equal on and specify the history table name, it went ahead and created that table because it doesn't exist. But if that table already exists and it has all the necessary metadata, specifically it's got matching metadata to the base table, and it's got these 3 directives, valid from column, valid to column, and then period for system time is defined, it will let me use that existing history table if I'm on the right database. Now it'll let me use that existing history table. So now if I go back and refresh the list of tables, we are back where we started. And in fact, because I use that existing history table, if I go back and look at for system time, let me find a different one. So using for system time all, irrespective of the customer ID, you can see that I returned 671 rows. Those were the 663 that we started with, plus those modifications that we made after the fact. So if you specify a table that doesn't exist, whenever you set up system versioning, it will create that table for you. If you specify an existing table name, assuming that it has the required metadata and it matches that existing table that you're turning on functionality for temporal tables, it'll automatically use the existing rows that you have in there, and it basically lets you import the history of what you already have in that temporal table. So again, temporal tables are really good for a couple of specific scenarios. If you want to track the history, if you need a fairly lightweight auditing mechanism and you don't need say full-on auditing of who changed it and things like that, temporal tables can be a really good option for something like that. Again, for those of you who deal with data warehouses, if you don't have the requirement to set an application time as the start and end point for those rows being created and expired, temporal tables can be a really good substitute for using slowly changing dimension type 1 and type 2 tables. So just a couple of things to wrap up. Ideal for keeping track of history. You do have to have SQL Server 2016 or later. Everything that I showed you in here, with the exception of that retention period, was specific to 2016. If you're using 2017, you can enable that retention period, but it's only a logical retention. All of your history is still kept in the underlying table. And then using temporal tables is almost completely transparent to your application. So if you need to insert, update, and delete, and you're replacing an existing table with a temporal table, the application really need not know that you're using a temporal table, because if you're just doing regular CRUD operations, it looks just like a regular table. The benefit that you get from that is if you're converting an existing table to a temporal table, the chances of it breaking your application or breaking some functionality within your application is very, very low, because it looks just like a regular table whenever you create an existing table and modify it for temporal functionality. All right, with that, that's the end of our presentation. Warwick, I'm going to open it up for any questions that we have or any other comments that we need to address.
Okay, so first question. Have you seen any controls for displaying data in an application that takes advantage of temporal tables to allow users to do ad hoc exploration of data to see what was changed and when to explore some sort of data issue in an application?
That's a great question. So I've seen that functionality directly in the database, where if we need to research some sort of issue and see the history, certainly it's easy enough to explore the data directly. But as far as embedding it in an application, I haven't seen that, at least with SQL Server. Honestly, I think that's probably just a function of maturity, because this is fairly new. There's a lot of organizations that they're not even on 2016 yet. So I think as this becomes more of a commonplace thing, because people are using the later versions of SQL Server, and application development tends to move a little more slowly than database development in a lot of cases, I think we will see that over time. But so far, I really haven't seen that as far as building it into an application.
Okay. Is there any guidance on how to extend temporal tables to include who made the change?
Great question. I don't believe, just using the temporal functionality, I don't believe there is a way to capture the information about who made the change. If you get into that territory, you're really getting into more than just history retention. You're getting into full-on audit capability. And that's really where you need to either turn on some of the auditing functionality that's built into SQL Server, or look at a third-party auditing tool to capture actually who made the change, maybe from what workstation it was made, and so on. So the short answer is no. For temporal tables, there's no easy way to capture that information just using the temporal functionality.
Could or does temporal table functionality work with the likes of change tracking or change data capture?
Does it work with change tracking or change data capture? I haven't used those in parallel, but I don't know of a reason that they wouldn't work together. Temporal tables really are going to stand alone as far as could you enable, say on the same table, enable temporal functionality as well as change tracking. Yes, I believe you could, but honestly, I think you probably wouldn't need both of those. If you're using temporal tables, for example, you're going to have a full history of when everything was changed, when the last row was updated, when a row's expired, and so on. So if you were to turn on, say, change tracking on a table that was enabled for temporal functionality, you've really got two moving parts that could be serviced by a single moving part. And I think the same could probably be said for change data capture. So if you're getting into change data capture, you're concerned about history retention as well as the auditing of the full auditing, who made the change to some extent, where it was made from, and so on, where change data capture can give you a little more of that information that temporal tables wouldn't. But again, if you were trying to track both of those sets of information, the full history as well as who made the change, I would think that you would probably go down the path of let's use change data capture instead of trying to turn both of those on. So the short answer is I think they would run in parallel, but I really don't think that you would need to run change tracking, or rather temporal tables and change tracking, or temporal tables and CDC at the same time on the same table.
Okay. Now, you mentioned the slight variation between 2016 and 2017. Is there anything new in 2019 that you're able to share?
I haven't seen any difference being implemented in 2019 that's not already in 2017.
Okay. With the temporal tables, is it possible to see what operation was undertaken on a row, i.e., was it an insert, an update, or a delete?
No, unfortunately, it doesn't. So if you're using, somebody mentioned change tracking earlier. If you're using change tracking, it's going to tell you for the change that was made, this was an insert, an update, or a delete. Unfortunately, temporal tables don't work that way, in that they won't show you what the change was. They simply show what the version of the row looked like. You could infer that information if you're querying either the base table or possibly combine the base table with the history table to see, did this row exist previously and now it doesn't? Hey, I know that's a delete. Or did that primary key exist before and it still exists in a different version? I know that was an update. But directly, no, it won't show you on the row itself. It won't show you this was an I, this was a U, or this was a D.
Okay. Are we able to use temporal tables with or for SCD3s?
Can you use them for SCD3s? That's a little bit of a tricky question. The short answer is yes. But in all my years of dealing with data warehouses, I've not really found a situation that I needed to use a slowly changing dimension of type 3, which basically stores the last value that you had previously. In all my exploits, and that's kind of a bigger question and certainly worth some exploration on its own. But I have not found the need to do anything in an SCD3 that I couldn't similarly do just as easily in an SCD2. But the short answer is, if you wanted to get the same result that you would get in an SCD3, you could do that with temporal tables, yes.
Okay, so we have got, here we go. I'm just waiting for another response to expand on the question, which was, can we use it with SQL Server replication?
Can you use it with replication? I'd be curious in what context, if you're using it as a publisher or a subscriber. Honestly, I haven't tried it in replication, either publishing, getting updates, or pushing updates, either way. I don't, this is conjecture because I haven't tried it. I don't think there's going to be an issue because if you want to turn it on for that base table, for example, the base table is just a physical table, and the functionality that does the insert, update, and delete operation, or more specifically, the insert and update on the underlying history table, that's an under the hood type operation. So everything that interacts with that SQL Server table, whether you're putting data into it or getting data out of it, is simply a CRUD operation. So anything that performs a CRUD operation, and from what I understand, replication does simply just apply those CRUD operations in sequential order. It's still going to work the same way, and you're still just touching that base table to do either the getting data into that table or writing data out to some subscriber elsewhere.
Okay, so if it was in your publisher and the particular table that you were using to get articles from, and you enabled that table as a temporal table, would that have any impact?
Again, I think I'd want to test it just to make sure. My shoot from the hip reaction is no, because it's still just a regular table that you can do just about anything else that you can do with a regular table. And I'd say with 95% certainty, yes, you could do that, but I want to test that just to make sure that I'm not giving you a wrong answer.
Okay. Now, if we've enabled a table to be a temporal table, are we able to modify the physical structure of that base table.
Yes, absolutely. In fact, if you, let's say you want to add a column, you can simply go into, so I'm still sharing my screen. If I wanted to add a column, I'll just show you that live real quick. Alter table customers. And I just hit a button I didn't mean to hit. This is why they tell you don't type in demos. Alter table customers, add some column int null. So modifying that existing table that we had. And now if I go, so all I did was I added a column to customers, but now if I select everything from customers history, go all the way off to the right, if I modify the metadata in some way on the base table, it will also perform the same modification on the underlying history table as well. So the short answer is yes, you can make a modification to that. Any material change that you make to that will also immediately be reflected in that history table as well.
Okay, now with enabling temporal tables, does that have a performance impact on our system?
That's a great question. So far, I had in all my uses of temporal tables, I have not seen any significant performance impact. Honestly, I think if I were looking for what the impact would be, I would certainly look for the velocity of changes, because if you're trickling data into a table, obviously you're going to have all of your data that you're updating or deleting will be reflected in your history table. If you've got some ETL process, for example, that modifies every row in your table every time, so if it's just blindly doing an update, irrespective of whether anything has changed, that's when I'm going to start to get a little bit nervous, not just from a performance perspective, but from a storage perspective as well. So if I've got 1 million people in my person or my customer dimension, excuse me, and my ETL process that runs every day is touching every one of those customers and doing a blind update. Even if nothing has changed, if I say update this column or update this row, set all these values to be X. If the values are already X and I'm setting it from X to X, it's still going to generate a history row in there. So if you're doing large scale updates like that every single day or even more frequently, that's really when you want to pay attention to, hey, maybe temporal tables is not a good option, or maybe I want to do something different where I'm turning off temporal tables when I do those large loads and then turning it back on after the load is done. But for pedestrian updates where if I've got 1 million customers and in any given day, maybe 100, 1,000 are changing or we're adding new rows slowly like that, I wouldn't be so worried about performance. And in the uses that I've seen, I haven't seen performance be an issue like that. But in those cases where you are doing wholesale large scale updates every single day, that's really where you'd really want to pay attention to not just performance, but how much data you're storing in that history table.
So as a summary, would it be fair to say that if you had, or if you enabled temporal tables on not necessarily a large number of tables, but those tables, as you mentioned, have a lot of change, the increase or storage utilization is something that you would definitely want to be concerned about, and should be something that you should think about using 2017 over 2016 so that you can set that retention period?
Absolutely. Yeah, if you do have a large velocity of changes, either the sheer number of changes or just percentage wise, if you've got a lot of data that's changing every time you run whatever updates you're running, you certainly want to pay attention to how you're storing that. Now, keep in mind, you mentioned the version, you mentioned 2017. Do keep in mind that even if you're using 2017 and you set your retention period to something less than infinity, where you set it for a month or a year or something along those lines, all those changes, all that history is still going to be in your history table, so it doesn't get purged out. The only impact is when you query that data later on and you say for system time as of X. If X predates that retention period that you specify, that data won't be returned in the query, but it's still going to be sitting on disk and occupying space and consuming index consumption. You have to, if you're rebuilding your indexes, it's automatically going to have to rebuild for the entire table and not just the part that you're using. So yeah, the short answer is yes, you certainly want to pay attention to the velocity of change. And if that change is significant enough on a given table, it may be that either temporal tables are not a good option for you, or you want to have some sort of manual purge process that you do periodically where you are removing those old expired rows so you don't clutter up that table indefinitely.
All right. I've got one. If you could recap just the difference between CDC or having what's captured in CDC and stored in CDC system tables and the temporal table.
Yeah, so that's a good question. So in temporal tables, it's simply the data itself. So if you've got 8 columns that you're storing, if you got 8 columns in your customer dimension, those 8 columns plus the valid from and valid to dates that you specify, those are really the only fields that you're storing. If you're going down the route of CDC, you do get some extra data. It shows, it's been a while since I've implemented CDC. It shows the account that made the change, when the change was made, I believe the effective operation, whether it was an insert, an update, or delete. So you get, with CDC, you get a little more metadata as far as who made the change, and that is more of an auditing tool than simply just a history tracking tool. Now it does track history fairly effectively, but it actually captures a little more information. One thing that I've seen with CDC is that it does capture a good deal of volume of information. By default, CDC doesn't keep that indefinitely, and I forget the period that it keeps that for by default. But just in terms of the space, because it's based on the transaction log, it doesn't keep everything indefinitely. So if you were looking for a full-on auditing tool to detect who made the change, when it was made, the type of change, insert, update, or delete, CDC might actually, for that table, might be a better option. But if all you care about is, I want to see the versioning, I want to see what the record looked like 3 days ago versus what it looked like right now, then temporal tables is typically the better way to go.
All right. Well, it looks like we don't have any more questions. The time is up. So I would like to thank Tim for his time. I would like to thank all of the attendees for coming along for this month's session. So make sure that you do register for next month's session, second Tuesday of the month, 12:30 p.m. Australian Eastern Standard Time. With that, I wish you all a good afternoon, good evening, and a good month. Thanks, everybody.
Thanks, everyone.